Okay, so this is the question number 2 for the review. What we have here is a 3D vector. The most important thing about this problem is remembering that f1 plus f2 plus f3 plus f4 plus this right here is going to equal to 0. So I'll write it down right here before we even start. F1 plus f2 plus f3 plus f4 plus 225 equals to 0. And if you can remember this, really, it says it on the questionnaire, the little, sorry, right here it says it. The particle in figure 1 is at equilibrium, which obviously it means that it equals to 0. So just keep that in mind as you do the problem, okay? Now the first thing to do is find out the F1. Remember, you're trying to find the forces of F1x, F1y, F1z. So to do so, what you're going to do is you're going to want to find the F1. So to find the F1x, it'll be cosine of 60. So you see me putting right here, cosine 60 times the force of F1, and that'll be I, which is x. And then for y, it would be cosine of 60 times F1 j, because that'll be the y. And then we do the same thing for the z axis. So as you can see, this angle right here that goes from the z axis to F1 is 135. So since the angle is not adjacent, we use the cosine of 135 times the force of 1, k. Okay, and then we pretty much do the same thing for every single force. For F2, where is it? F2 is right here. It's in the z-axis. So automatically, right off the bat, we know that it's going to be 0x, 0y. So the only one that's going to have a value will be k. So since it doesn't have a direction, since the direction's on the z-axis, it's going to be F2. That's just going to be F2k because it's on the z-axis. Then we do the same thing for F3. Then again, it's on the y-axis and it's going down. Remember that this is positive, that is positive, and that is positive. I'm going to do it green so you guys know. That's positive, positive, positive. And the negative would be going down, going that way, and going that way would be negative. So just keep that in mind. So F3, the forces on the y-axis is going to be negative F3, and there's the components, and the z and the x don't matter. So we're going to do the same exact thing for F4. And remember, F4, they already give you what the force is 165. So what we do is the following. The first thing we want to find is I, so it's relative to the x-axis. So it's cosine of 45, because this right here, this angle, if you want to find you have to take the cosine of 30, because this is the angle it makes when it's reflected over the x-axis. Okay, so it's cosine of 30 times the cosine of 40, because this angle is touching the x-axis, minus, because it's pointing that way. So it would be minus the cosine of 45, again, the 45 is touching this xy plane, times the sine of 30, because the sine is the opposite. We're trying to find this angle right here, and you want to use the sine of 30, times 165 again, because it's a force of F4, plus, and again it's plus because it's pointing up, and as we can tell here, it's a positive, sine of 45. The reason it's sine of 45 is because this angle right here is 45, and we're trying to find this angle. Since this is 45, we use sine of 45 to find this angle. It's right here, times the 165, the force. Remember, you only need to find, it's only sine of 45 as opposed to cosine of sine of 30 right here, because we're finding it on the y's, like on the y plane, so we only use this one. So once we have these four, what we do next is we want to put the I together, the j together, and the k together. So starting with the I, when you're putting the I together, you're gonna go here. So you're gonna go here, F1. You're gonna put it here, cosine of 60 times F1, because it's an I. And then you're gonna go down the line. F2 doesn't have any, F3 doesn't have any, and F4 does have one. So you're gonna put the cosine of 45 times cosine of 30 times 165. And then you're going to use minus 225 because it is the force, it's the force of the fifth, and you have to equal it to 0. You have to use it so you can equal it to 0. So when you solve for it, you can see that F1 is 248. And then you're going to do the same exact thing for F2, F3. So here you're going to find the J. So you're going to take, for example, this one. You're going to take this one. You're going to take this one. And you're going to put it together in an equation. So it'll be cosine of 60 times F1, and F1's we already know what it is, it's 248. Put it here, minus F3, it's right here, minus 58.34, which is what this equals to. Equals 0, you solve for it, and you get your F3. And you're going to do the same exact thing for the K, and you're going to get your F2. So you're going to do your F2K, you can see here, and now you don't have to put the K and the I and the J in when you're breaking it down into these. You're going to use this one, you're going to use this one, and you're going to use this one. You're going to equal it to 0. As you can see, you get your F2, 58.7. That's pretty much it.